Have you ever wondered what your life would be like if at some crossroad you had made a different choice? Stayed with that certain love interest? Or taken a different career path? According to recent discoveries in quantum mechanics, the scientific concept of a multiverse has reached mainstream popularity. The theory says that other universes like and unlike our own exist beyond this one in a vast sea of space, or that they could even be woven into the dimensionality of our own universe. If these other universes exist, each one could have a completely different law of physics. Matter may not even exist. Events could flow in reverse order. Or they could have life forms so bizarre they are unimaginable to us. On the other hand, other universes could hold worlds almost identical to ours, with exact duplicates of everything everywhere, including duplicates of you living a story you didn't choose to live in this lifetime. Though it may sound like science fiction, metaphysics, or even religion, the multiverse theory is actually based on pure math and logic, and scientists keep coming back to it because it offers the best explanation for some of the biggest paradoxes in physics. So, if you'd like to hear a simplified explanation of the science supporting the multiverse theory, join the universe inside you, create a new reality, and have some fun imagining what the other versions of you may be doing in parallel universes. What is the universe? It's often thought to mean all that is, but in fact, the universe is a specific area in space which has been expanding since its creation in an instant, a moment we call the Big Bang, which occurred billions of years ago. To grasp just how expansive the universe is, compare the size of our planet to the size of the Sun. The Sun to larger stars, including stars so enormous they exceed the distance of our own solar system. Then, remembering that stars are collected into vast groups known as galaxies, consider that our galaxy, the Milky Way, holds an estimated 100,000 million stars. If you were able to leave our galaxy, you'd find many, many more galaxies like the Milky Way. In fact, there are at least 100 billion more galaxies in our universe, each having 100,000 million stars of their own. And far beyond the most distant ones is the edge of the universe's expansion, an area called the end of the observable universe. Technically, this term refers to the distance light has traveled in 13.7 billion years since the moment of the Big Bang. Now, imagine there are not just 2, 3, or 10, or even 100 of these vast universe bubbles, but an infinite number of universes, just like and including our own. The definition of multiverse is an infinite group of these vast universes comprising everything that exists, the entirety of space, time, matter, energy, even the physical laws and the mathematical constants that describe them. These either coexist like bubbles in the great sea of space beyond the end of our observable universe, or they are somehow woven into space-time within various dimensions of our universe. No doubt, it's dizzying to contemplate. So we wonder, naturally, what events and observations would lead scientists to confidently propose such a fantastic concept at the risk of their credibility. It started in 1957, when a Princeton graduate student named Hugh Everett III wrote a thesis entitled the theory of the universal wave function. In it, he proposed that the mathematics of quantum mechanics reveals something remarkable: the continuous forming and breaking at right angles of spherical symmetry at the quantum level, which causes reality to constantly split and make new timelines. This makes all possible outcomes to every situation equally real in parallel universes. What does this mean? It implies that any time atomic particles interact with each other, or with anything else, anywhere in the entire universe, there are multiple possible outcomes. At the most microscopic level, these quantum particles then branch into different outcomes and become separate realities, essentially splitting history to create both timelines and entirely new worlds, all the time and everywhere in our universe. This is now known as the many worlds interpretation, where every moment in life, in the interaction with a quantum system, creates the effect of every possible decision and every possible story. So what does this mean to you? It would mean that although it appears you're living only one lifetime, every possible life path you could ever have lived is happening, including the unchosen path of every decision you've ever made. Every version of you exists out there. You just happen to be focused in this reality, experiencing this branch of your timeline. Not surprisingly, since Everett was still a graduate student and not very well known, the many worlds theory was scorned by the scientific community at that time, despite mathematical accuracy. It's likely that two more reasons made and still make this theory unpopular. First, the incredible existential crisis induced by the idea of infinite versions of one's self. Secondly, the inconceivable number of timelines or worlds that would exist as a result of all possible outcomes manifesting from every quantum interaction in this universe since the Big Bang. When the hypothesis resurfaced years later, with new discussions about dimensionality, the many worlds theory received a very different reception. Unfortunately, Hugh Everett III died relatively young, but was labeled a genius for the theory he proposed well ahead of its time. The multiverse theory came front and center again, thanks to the work of a cosmologist named Alan Guth. In 1979, Guth, who later became an MIT professor, was trying to understand how particles formed in the universe, and it led him to study what happened in the first moments after the Big Bang. He knew that as energy discharged in space, it rapidly transformed into tiny particles of matter. When he applied new particle theories to existing ones, he realized that in order for the universe to expand so far and so fast, there had to be some kind of repulsive gravity, repelling everything around it. This would explain how a space as tiny as a molecule could become as huge as a galaxy in a fraction of a second. Guth called this rapid expansion inflation. Fortunately, Guth's theory made predictions that could be tested through observation. In the night sky, there is a warm glow not related to stars, but caused by cosmic microwave radiation that is a remnant of the heat of the Big Bang itself. If his theory of inflation were correct, there would be measurable temperature differences in this sea of radiation as a result of the violent expansion of that moment in time billions of years ago. In 2001, NASA confirmed it. the temperature variations in the cosmos exactly matched those predicted by Guth's theory. The result made Guth a science celebrity. Then, Russian scientist Alex Vilenkin took this theory to a new level. Understanding that outside our universe, space must be uniformly filled with a huge amount of energy on a cosmic scale, and understanding that inflation wouldn't have ended with the Big Bang, Vilenkin proposed that energy must continue to discharge, creating more Big Bangs, and therefore more space-time bubbles or universes all around. Vilenkin proposed that these universes must be eternally exploding from the discharging energy and expanding just like our universe is. This process, eternal inflation, would go on infinitely in the vast sea of space beyond our observable universe, and nothing, not even light, could reach from one universe to another. Today, many cosmologists continue to search our observable universe for any kind of indication of other universes, such as signs that it may have collided with another. They've yet to find it, but it remains a very real possibility they will. So, the multiverse theory supported the concept of eternal inflation by answering the question, what lies beyond the end of our observable universe? Then, the multiverse theory got even more leverage from another surprising discovery in cosmology. Around this time, astronomers learned that despite what natural laws would indicate about movement slowing over time, our universe's expansion from the Big Bang was not slowing down. On the contrary, it was, and is, speeding up. This fact baffled scientists and prompted them to measure the energy responsible for pushing galaxies apart at a faster and faster rate. Consequentially, what they discovered was even more shocking. The amount of energy responsible for this acceleration is trillions and trillions of times smaller than expected. So minute, in fact, that on paper, it's a decimal point followed by 122 zeros, and then a 1. This minuscule value is hardly a match to the incredible power responsible for moving galaxies. And yet, this mysterious quantum force, called dark energy, is so formidable, the slightest adjustment to the amount of it could completely change what exists in the universe. For example, if you slightly increase the amount of dark energy, the force of expansion would be so fast and strong, matter simply would not form or exist. If you slightly decrease the amount of dark energy, the universe could actually collapse into itself. Suddenly, it became evident that we have taken life and the exquisite nature of our universe for granted. The conundrum? With odds even lower than winning a lottery ticket, our universe somehow got just the right value of dark energy to ensure that stars, galaxies, planets, atoms, and life itself could exist. How could this have happened when the likelihood was so implausible? The answer again led scientists to point to the most fantastic of theories, the multiverse. Because if there are trillions of universes, then every possible situation would exist, including every amount of the force that creates universes. In other words, the crazy exact minuscule value of dark energy required to form matter would occur if all values of it occurred in different universes. support for the multiverse scored again. Then, one more door opened, which appeared to support the theory of the multiverse. This time, it came full circle to Everett's many worlds theory, exploring the role of dimensionality in creating parallel universes. String theory is a mathematical model that describes everything, all fundamental forces and forms of matter. The strings are thought to be the most minute substance. How small? Well, inside atoms are protons and neutrons, and in these are even smaller particles called quarks and neutrinos, too small to measure. And in these are thought to be tiny strings, or loops of energy, which are the single ingredient responsible for creating everything that exists. In fact, string theory is often called elegant simplicity because it proposes that everything we know comes from one master equation. But if string theory is correct, the math requires something that defies common sense, and again leads us right back to the multiverse. String theory requires multiple dimensions. It's well accepted that height, width, and depth are not the only dimensions of the space we inhabit. While we only see 3 dimensions, string theory proposes that there are at least 10 dimensions, and that's just a start. These extra dimensions are said to be right here, crumpled to a tiny size. And even though they are all around us, we cannot see them, even with the most powerful equipment. To understand what this means, imagine looking at a traffic light from a distance. Then, imagine being an ant crawling on one of the poles of that light. You'd experience another perspective, one that curls around the pole, creating a different dimension. String theory says that if we could shrink down many times smaller than that ant, we'd find extra dimensions curled up like this inside every bit of space. Since the shape of these dimensions determines how the strings vibrate, and the vibrational patterns determine particle properties, these dimensional shapes then determine what particles are and what exists. You could say strings are to reality what DNA is to life. So, where does the multiverse come in? The more string theory was studied, the more apparent it became that math could not reveal how many shapes the extra dimensions could hold, or which shape was even the one corresponding to our universe. The number of possible shapes is so incredibly high. 10 to the 500 zeros, the infinite number, simply implies that there must be a multiverse, where all quantum possibilities could be created in a multitude of dimensions. So, logic has 3 lines of reasoning which lead back to the theory of the multiverse: eternal inflation, dark energy, and string theory. And each of these requires an infinite number of realities in order to make sense. Of course, as we said, the multiverse theory has yet to be proven because it will require that predictions can be tested through observation. Considering the miraculous conditions that allow this universe to exist, we can't help but wonder how we got so lucky. If the multiverse theory is true, what other universes do exist? Worlds without life? Even worlds without stars and matter? Or worlds with every version of you in that different job, country, or different family? Even if you don't believe the multiverse exists, it's okay, because if it does, somewhere in another reality, another version of you believes it. Thank you for watching, and hit the like button if you enjoyed this video. We hope you'll subscribe, and if you'd like to be notified of future releases, just hit the bell button.